Section 4.2, look, we are going to be working with a lot of the unit circle stuff, and I'm going to do two problems today. I'm going to evaluate one of the trig functions. I'm going to find the cosine of some radian measure on the unit circle, and doing one where they give you a radian measure that's over 2 pi, and I'll show you a couple different ways that you can do this one. You can pick with the one you like. And then the second problem is they're going to give you the sine of some random angle, which we don't know what it is, and they'll tell us what the actual sine is, and then they're going to ask us to find the sine of, and it could be anything, but the two I have written down are the sine of pi minus t and t plus pi, which of course t is the angle that they're referring to. And I'll show you the way I like to do that problem. Alright, so looking at the first one, it's going to ask us to evaluate the cosine of negative 14 pi over 3. Couple things I want to look at. First thing I always suggest you do is, ignoring the pi, can you take that fraction and simplify it at all? If you can't, you should be able to look at the denominator and already know pretty much what the answer is. Because I see the 3 in the denominator, I know this is a 60-degree reference angle. So I know the point at 60 degrees is 1/2 square root of 3 over 2. It's asking me to find the cosine. I know my answer is either 1/2 or negative 1/2, and I can tell that just by looking at the problem. Nothing I really even need to do. Now obviously I'm not done. That is a big part of it, but I need to figure out which quadrant it's in to figure out, is this actually a positive 1/2 or is it a negative 1/2? And so you can do a couple things. For right now, ignore the fact this is negative. Let's pretend that's positive 14 pi over 3. If you have a number that's not within 0 and 2 pi, you can always subtract 2 pi from it or add 2 pi to it over and over and over until you get a number between 0 and 2 pi. So for example, it's negative 14 pi over 3. I could add 2 pi, which if I get a common denominator would be 6 pi over 3. That would give me negative 8 pi over 3. Well, that's not between 0 and 2 pi, positive, so I'm going to add 2 pi again. And I just keep doing this until I get a number that's in between positive, or between 0 and positive 2 pi. Still not working, so I'm going to add 6 pi over 3 again, and I find out that this is actually 4 pi over 3, which if I know my unit circle really well, I know is in that quadrant. And now because I have to move to the left, I know that my answer is negative 1/2. So if you're going to do it that way, that's fine. Show me the work. Show me the quadrant that you're looking at so that I know why you're using that. Because remember, if by accident you pick that quadrant, you're still going to say negative 1/2 because you moved to the left because it's a cosine, but you're actually wrong. So if I don't see that picture, I'm just going to assume that you're wrong. Make sure that you're showing me that. Alright, now yes, that works and that's nice, but what if this angle is negative 1,477 pi over 3? Are you really going to add 2 pi over and over and over and over again? Probably not going to want to. So this is the other thing that you can do. You can take that basically mixed number, or improper fraction, and change it to a mixed number. You notice I'm ignoring pi for right now. If I take 14 and divide it by 3, I know that 3 will go in there evenly 4 times, and I have a remainder of 2. So another way of writing negative 14 pi over 3 would be to say negative 4 with a remainder of 2 pi over 3. And so, if I go about doing this, I can say, well, let's go ahead and draw myself a little picture here. It's negative 4 and then 2 pi over 3. Now, it's negative, so remember when you start measuring from here, you're going that direction. So, and just to guide myself, starting here, remember what we did in class. Anytime you count, this is 1, 2, 3, 4. All the odd numbers here, even numbers here. So regardless of what number that is, since it's even, you eventually are going to end up over here. That accounts for the 4. I still need to move 2 pi over 3, which here's 1, there's the second one. And of course I end up at the exact same spot I did over here, and I should. Alright, that's one way of looking at it. Now if you want to ignore the negative, you can do that and say, I'm going to go the positive direction, I'll worry about the negative at the end. Just don't forget about it, of course. 4, regardless of what the number is, even if that was 114, it's positive, so it's eventually going to end up here. Move 2 pi over 3 would put you here, Now, just like any other function on a graph, if you make the function negative, it reflects over the x-axis. This would just jump down here and would be here. So it's whichever thing you like doing. Me personally, because if you get a gigantic number, which very well could happen to you on the test, you're not going to want to sit and add 2 pi. That may take you 15 minutes just to add 2 pi over and over and over and over again. So what could you do instead? You could do this. Do the long division, change it to a mixed number, look at whether this is even or odd so you know whether to start here or here, and then move that distance. Make sure you're paying attention to the positive and negative. If you want to ignore the negative and just reflect, you can do that too. You're always more than happy to come in and ask me for help if that doesn't make sense to you. Alright, the last problem I'll do is kind of like, I think it's sort of like in the 40s, 30s, and 40s somewhere, where they say the sine of some negative angle is equal to 3/8. They want you to find the sine of pi minus that angle and the sine of that angle plus pi. And so if I draw a picture to represent this, which is what this section is dealing with, not trying to memorize a lot of different formulas, which we could try to do, it's more being able to draw a picture and understand what's happening. Alright, this is a negative angle. It has a sine that is positive. The sine is positive either here or here, which means technically, because I'm measuring from here, this is angle t. It's negative t, so it would be like negative whatever, or this is negative t. Doesn't matter which one I pick. Alright, here's what I like to do, and I like to do this to see what's happening. If they ever give you an angle like this, pick something that you know on the unit circle that will make sense, and I always say pick 30 or 60. I always say just pick 30. It's easier that way. So I'm going to pretend like this is the sine of negative 30. Right? So right now I'm kind of ignoring this. I'm asking myself, the sine of negative 30. Well, negative 30 is right here. The y value is negative 1/2, because the point here is the square root of 3 over 2, negative 1/2. So there's the sine of it. Alright, so I'm pretending like t is negative 30. Well, let's pretend for letter A that that's still true. If I have the sine of pi, which is really 180 degrees, minus a negative 30, really I'm trying to find the sine of 210 degrees, which I know the sine of 210 degrees is in the third quadrant. And I know because I had to go down that, again, the x value is negative square root of 3 over 2, but that's not what they're looking for. They're looking for the y value. It's negative 1/2. Well, here's my point. If you look at the original picture that I drew, it was negative 1/2 to start with. It still is negative 1/2. It didn't change. What does that mean? That means that number's not going to change for this problem, regardless of what that is and regardless of what that angle is. Whatever this is, it's going to stay the same, because I noticed here it never changed. Again, I just randomly picked negative 30 to be my t value. I could pick really whatever I want. You don't want to pick 45. That's a bad idea. But like I said, just pick 30. It'll always work for you. Pick 30. Think about what you actually would get at negative 30 degrees here. Go ahead and plug negative 30 in here. Evaluate it, and then ask yourself, did it change? And if it did change, what changed? It didn't, so I know the answer. Alright, so now let's think about doing that for letter B. If I take the sine of, if I say t is negative 30, that's negative 30 plus pi, or 180. Well, that's actually the sine of 150 degrees. So I draw my little circle, and 150 degrees I know is over here. This is negative square root of 3 over 2, positive 1/2. They want to know the sine, they want the y value. It's positive 1/2. What was it originally? Negative 1/2. So what do you think is going to happen up here? The sine's going to change. It's negative 3/8. So kind of a neat little trick where you can put 30 in for any angle that they give you, figure out what the actual point is, evaluate using that angle of 30, and then whatever happens to your y values or x values, you can look at it and say, oh yeah, it switched signs or it switched places or whatever the case may be. You'll get a lot more practice of this in a couple sections coming up, but this is a big idea, so if you have trouble, make sure you let me know.